Good morning. Today we're going to be taking a look in our database design and development course about how to do simple SQL or squirrel selection. This is Cody Hendrickson. Let's go ahead and get started. So when we're talking about databases, the biggest thing we're most often working about is talking about extracting data, especially on the beginning side of working with databases. That's the main thing we're working at doing. And when we're extracting data from a database, we have a couple questions that we really need to be asking, and so that we can actually understand what we're doing with that database, or okay, why we're using it in the first place. The key questions we have to answer when we're using a database are the following. The first, what do we need? Second, where is the data located? Third, is there some certain data we actually care about? And fourth, do we need to organize the data? I don't know. We'll find out. So these are the questions that you want to keep in mind as we're actually looking at and working with databases. So as we work today, make sure you keep those questions in mind as we go along. So let's go first and take a look at getting data out of it. The first thing we want to talk about is exploring the data. We have the fact that the structure of a database. The database itself is made up of tables, and the tables are made up of fields, aka columns. So that's the actual structure we see when we're talking about databases. Now, the next thing we can do is if we have the advantage of having an ER diagram or an entity relation diagram, we can actually take a look and see a visual representation of what that data is. And it's an amazing tool. Total double thumbs up so we can actually look at that. But unfortunately, when we have an entity relationship diagram, that sometimes is not always provided to us, especially when we're coming to the game after the fact. We're looking at data that we just simply have been assigned as an assignment, or say, for example, data was created way before us and we have no reference or documentation to start off with. Or, in the case of academics, hey, you've got a test question, you've got some data to have to work with, and here's what you get. So we don't always get an entity relationship diagram, and so one of the best ways to explore the data is to use queries to find out what's going on. And this is a great way to introduce ourselves to a database itself, provided, of course, we know the tables. So when we're doing this, we're going to use a query to actually understand this, the exploration query, and we don't know what's inside it, so we're going to take a quick look. And the way we're going to use this is using a wildcard to get everything out of the data. So the first thing we have to do is we have our select keyword. The select keyword is how I retrieve data out of any database. We're going to use it all the time. It's a big one, I know. The asterisk is the modifier that's a wildcard that allows us to get absolutely everything out of a database. It gives us every single column that exists. So it's an amazing tool to use. And then the from keyword tells us which table we're talking about. And so I want to get everything out of the database. Now, Veruca Salt is a fantastic idea for this. I don't care how, I want it now. Veruca's got the right idea. We want everything out of this. So we'll do this. The wildcard selection is what gives us everything. The metadata are the headers. And again, this isn't mean we're talking about what we're looking at and we're about data. So that information we're going to need to know later. And especially as you're exploring a database, one of the most important things to do is to keep track of the column names because you'll probably need them later on. So I encourage you, if you're working on this as an academic enterprise, if you're working on this as a programming or other exercise to explore databases, track what you're doing. Have a document or have another piece of notepad paper or something you're working on so you can see, oh, this is what I'm working with. And so write that down. You want to keep track of the information because that's how you're going to be able to identify this. So even if you don't have an ER diagram you can visualize with, you still have some form of notes you can look at yourself and work with. If you want to get everything, here's an example of a squirrel statement or SQL statement that'll get everything out of this applied table. So again, we have our select keyword. We have our asterisk, which is our wildcard modifier to get every single field inside that table. And then we use our from keyword and the table name we're specified. So again, we have the example right here. This is a great example. As you can see, everything that goes inside a very, very basic but huge pile of stuff to get information out of it. And again, also one little quick note, we have dash for comments inside Squirrel for single line comments. Good to go. What data do we need? When we're talking about this, most often the Veruca Salt approach, aka select asterisk from, no, not what we really want to do. We don't need to be that greedy, that obsessive with information. So Veruca, although fantastic as a human being character, no. Because of the select all gives us so many huge piles of data, we really want to take in mind that most of the time, Veruca's Salt approach, not what we want to take. We actually want to take a good look at what data we really need. So again, after we run that select statement, we're going to have on screen or on our report that we're looking at, the columns and the field names of the stuff that actually exist inside that database. And that's going to be very helpful to look at. So after we see all of the columns, this is where we want to take a look at and see, oh, this looks important and that looks important, or this looks interesting, nifty, cool. We want to look at what's inside it. And then we can also see by looking at the select all from the table that we can see what's inside those values because we can see the patterns of information that show up as we run that select statement. And this is basically where it comes to. We're going to be asking for specifics because when we're dealing with Squirrel or SQL, most of the time when we're talking to the database, especially when we're getting data, we are asking questions. And these are the question details that we want to get because just like when you're talking to teachers, your parents as a small child, they always want more details so they can actually figure out what's going on. So another thing we have to keep in mind with this is order is important. So a clause is what makes up a component of a squirrel statement. And so we have some clauses we have to keep in mind. The required clauses are bolded right here, select and from. You have to have those two at a minimum. The next two clauses, where and order by, are also important and helpful, but they are optional. So they're italicized because you don't have to have them. The order by clause must be the last clause in a query if you're going to do sorting on that. So again, that must be last. Nice little parenthetical to keep a track of that. Now, where is the data? What are we looking for? So again, when we did that earlier approach, we took those notes and we actually wrote down the different columns we want to look at. That's the data we want to look at. So we want to look at our single table queries, and we want to look at the columns of information that have what we need. And like I said, Veruca's salt approach, probably not the best choice. So we want to make sure we understand the syntax so we can do some basic extractions of data using simple table queries. And so we're going to practice with that and do a lot with that. But we want to make sure that we get that understood and we understand how that relationship exists before we move on to the more complex and powerful queries, because it's great to understand the nice little table, and then we can use that information to do the little thing to do the much bigger but cooler thing at the same time. So we first need to identify which table actually is involved. So again, when we're looking at all the tables, we want to identify that. And so again, when you take notes on your piece of paper and you track the information, make sure you identify what fields go to which table, because you're going to need to know which table actually has the information you're looking for, especially because of foreign keys. They may have a name that sounds like something you're actually looking for in the table, but when you look at it, it's like, oh, that's a really weird number looking, or that's a hash value. It's great, it's unique, but that doesn't mean what I thought it meant by looking at the table. And so you have to make sure you're closely looking at what that data is. So make sure you look at the tables and identify what table you're looking at before you try and run those queries to find the information. So here we have an example of using fields to get data. So we earlier saw the select all, which gave us absolutely everything. Now we're going to go ahead and we're going to grab less. Now we're going to go ahead and grab some less data from that. So I want to get only in one field, so I use the select keyword as always. And then instead of an asterisk, I put a field name. And again, please note that when we're talking about fields, we use the snake case structure. So it goes all lowercase with separated by underbars, so we can actually keep track of it. Because again, although Squirrel is not case sensitive, the systems it runs on, Unix, Linux, even Windows sometimes, are case sensitive. So we have to make sure that we have the information in a case sensitive way that we can keep track of it ourselves for humans. And it's a great way to keep track of good coding standards. Then again, we have our from keyword, and then the table name followed by our amazing friend, the semicolon, which, although not required to end every statement, is a great policy to end all statements with, because you then know yourself, oh, I'm done. And so it's a great thing to have that done. So that gets all the values that are inside that field. So that's a tall, skinny column, and it's still really tall, lots of rows. But it's only one column, not all the columns. We also have another example to get multiple fields. In this case, I wrote n, this n is 3. And you notice that when we're doing a selection of multiple fields, we have the same field name approach, then a comma, another field, a comma again, and finally the last field or fields that we're working with that does not have a comma after it. So you can have as many fields as you want inside that select statement. So you can select 1, 2, 3, 4, 35. But you separate all of them except for the last with commas so you can keep track of each of those values. And again, if all in one table query, there's just one table name you're selecting it from. And of course, because it's our good friend, the semicolon's right there as well. Now, do we really need all this data? Now, we saw already from the select all and the select individual rows that we have this giant pile of information when we're running these queries against our databases. Now, if our database has 5,000 rows, 400,000 rows, 2+ billion rows, I don't need one column with all that in there. And so we often have to actually reduce the amount of data we're looking for. That data is excessive. So to get rid of that too many rows problem, we have to narrow our focus. This is like using an if block inside Java or Swift when you're trying to narrow the results of something. It's like, oh, I've got this condition, I can go in here. Instead of having an if block like you do in Java and Swift, we use a different approach for this. One of the main things we're going to use to limit the data sources are going to use some wildcard and relational operators. So first we have our wildcard operators. The two wildcard operators we're going to use on a regular basis when we're talking about results are the % and the underscore. The % represents anywhere from 0 to many items in front of or behind a value. So if I have % car, it can be car, a car, B car, C car, but it cannot be something that has, car, like George won't work because there's no in front of that would then give car. Or you can have it after the value. So I can have cars if it was, example, car %. So I could have cars, car ball. The next one is the underscore or underbar. And the underbar represents exactly 1 or 0 values. So I can have race car with a %, But underscore car won't work for that because race car doesn't have one single letter that can replace and get out of that. So the underscore represents either 1 or 0 values. The percent sign represents 0 or n values. Then we have, of course, our regular relational operators we use all the time when we're doing math operations, less than, greater than, equal. Notice that here when we're talking about squirrel or SQL or SQL, that's a single equal sign when you're comparing values. I know I've been drilling it into you when you're doing comparisons inside Java and Swift, we have equals equals, but squirrel, SQL, SQL, a little bit different. So again, make sure you keep your context in mind when you're looking at comparisons for this. There's also the regular not equals. Sometimes there's even a different version. We'll talk about it for older SQL queries, but we don't have to worry about that right now. And greater than or less than or equal to. Good to go. Now, the way we do that, the way we understand a restriction on that is with a where clause. Again, as mentioned earlier, the where clause is optional, so it goes after the from. So select everything from table name, but only where field value is less than 1, 2, 3, 4. So this is going to get everything out of the table name, grabs all the stuff, but then it filters it down to only the values whose field value is less than 1,234. Using the wildcards, so I have select everything from table name where field is like percent sign database percent sign. So I can have anything it wants in front of database and anything it wants after database. It just has to have database with a capital D inside there. So that way I can restrict all the results from the entire thing only down to the ones that have database inside that field name. So we have the ability to really shrink down that number of rows so it's no longer quite as excessive, and we can really reduce the amount of information we're working with simply by using a simple where clause. If we have a more compound or complex where clause, we can really shrink that data set down to very manageable levels. But simply by using that where clause, that's often enough, especially in early database projects or exploration, to identify the main concepts we're looking for. So where clause is how I reduce the data set, and it's an optional clause that comes after the from clause. Now, organization. Databases are amazing tools, but organization is not what they're really talking about. Organization is a side note, an after effect, something we can do later. So by default, relational data is unsorted. We have no sort to it at all. The way we sort information is we use the way we sort information is by using the command order by. And you can sort fields that are not even already specified inside your query. So you can select a whole bunch of things from it and sort by another field inside that table, even if you didn't select it out of there, because the information is still stored inside it. Really cool. Now, the way you sort things using order by is you have two different options. You can either go ascending, aka the values go from small to big, or you can go descending. They go from big, yes, that's right, to small. Now, the ascending one is the default, so you don't have to use the ASC keyword after the column you're sorting by, but it's often a good choice. And you can also do compound sorts by separating them You can do compound sorts by separating each part of the clause with commas. So I can have this field ascending, but that field, comma, descending. So I can have really cool compound sorts and do really fun stuff. And it's a great way to actually generate information for the people who are using that data. And we'll talk more about this as we go along. Here we have right here Elle Woods demonstrating those amazing skills because organization is key. And we want to be like Elle Woods when we're going to law school because we want to know what we're doing. Now, here's an example of the order by in use. So I'm going to select everything from table name. I'm going to limit that data by using a field like percent sign database percent sign. And then to make it so it's more useful for me as a human being, I'm going to use order by field value going descending. Even though field value is not my sort one, because it's part of that table, I still have access to it, and I can sort it by that going downwards. Or I can use select everything from table name, and I want where field is like database again, but this time I want to order by the field sign ascending, so it's going to go up in value. Really cool, and that uses a default alphabetic sort on that. So you can use some really cool stuff, and it has amazing features we can play with. And we'll talk about this and do some examples of this with actual code as we go along. But this is the basic structure you use. Here is the basic example of how you can build a very simple query using those four major clauses and how you can organize the information with them.